So here's another pre-calc final exam question. Solve the following equation algebraically over the interval between 0 and 2 pi, and the 0 and 2 pi are included because of the square brackets there. So the first thing you need to do to this is look at this as a trinomial. It's a quadratic. So you look at this as if it was 6x squared plus sine x minus 1. So if I'm going to factor that, I'm going to get sine theta in brackets, sine theta equals 0. So now I multiply the 6 and the negative 1. So what multiplies to give you a negative 6, because 6 times negative 1 give me negative 6. And then the number right here, the coefficient of sine x is 1. So what adds to give you 1? And the two numbers that do that for you are 3 and negative 2, because 3 times negative 2 give you negative 6, what multiplies 2, and 3 minus 2 give you 1. So I write sine minus 2 and sine plus 3. These are the two factors. For any of you who are not used to my factoring method, when I do this, because I have a leading coefficient that is 6, I divide this by 6 and I divide this by 6. And therefore I get sine theta minus 1/3 and sine theta plus 1/2 equals 0. Now I could see as one of the solutions is sine theta equals 1/3, and the other one is sine theta equals negative 1/2. Now we have to go ahead and find the angle. So for sine theta equals 1/3, we do our quadrants. All students take calculus. That's 0 to 2 pi right there. That's pi over 2, even though you're not going to use this angle for this kind of question, but you're going to use the pi. And here's 3 pi over 2, and we don't use that either. So the first one, sine theta equals 1/3. The sign is positive in the first quadrant because all of them are positive here, and where the sign is positive. So these are my two terminal arms. And the next step I'm going to do, see here, this is not a special angle triangle. This 1/3, we don't have this in a special angle triangle. So you have to use the calculator. This is a calculator question. So what do we do when we want to use the calculator? We want to make sure that we go set our calculator to radians mode, since they're asking me between 0 and 2 pi. I go second function, sine 1/3, and that will give me my reference angle, and my reference angle here is 0.34. So I write that in here and in here. Now always you're measuring the angle from 0. So your theta 1 right here, the first angle, is 0.34, because if your angle is in the first quadrant is the same as the reference angle. The second one you measure from 0 again to here. So what you want to do for theta 2 here, because you're right here, you go all the way to pi and take away that 0.34. So theta 2 will equal pi minus 0.34, which gives me 2.80. 2 decimals. So that's my theta 2. Now how about sine theta equals negative 1/2? So sine theta equals negative 1/2. It's a special angle triangle. It's the 30 degrees, 60, 1, √3, 2, and then you do the same thing. All students take calculus. 0 to pi, pi. As I said, you don't use the pi over 2 and the 3 pi over 2 when you're finding the angle and standard position in this kind of situation right here. So here the sign is negative, so it's not here and there. It's the other in the other quadrants, in quadrant 3 and quadrant 4. And the angle that has a sine of a half is the 30 degrees, because sine 30 is 1/2, but we want it in radians because we're working with radians, and 30 degrees is the same as pi over 6. And therefore, this is pi over 6, the reference angle right here. And the reference angle here is the same as pi over 6, but we're interested in this angle first. And this angle here, which is theta 3, if you wish, would be pi plus pi over 6, because you're going all the way to pi and adding the pi over 6. And that's going to give you, if you do common denominator, that's over 1. So I multiply top and bottom by 6. So that's 6 pi over 6 plus pi over 6 gives me 7 pi over 6. And theta 4 would equal, you're trying to find this now, all the way to here. So if you want to find all the way to here from 0, you just go all the way to 2 pi and take away the pi over 6. So 2 pi minus pi over 6, which equals 2 pi is the same as 12 pi over 6 minus pi over 6. And that gives you 11 pi over 6. So therefore, these are your 4 answers. This, and this. These are special angles, so we could give them exact values. This is not a special angle, so our answers, we could only do it in decimal. You could also do that in decimal. If they don't say exact values, you have the choice to use decimal all the time. So just use your calculator instead of special angle triangle. But one advice though, make sure you know your special angle triangles, because in grade 12, you need to know your special angle triangles, because they're going to ask you a lot of exact value questions. Okay. Let's move to the next question. So the next question is transformations. So with this question in particular, you have this function, f of x, and they want to sketch the graph of this, y equals f of brackets negative x plus 4, close the brackets. So there are transformations there. The first thing you want to do is rewrite this as y equals f brackets, take out the negative, and you're going to get x minus 4. So when you look at this, because the negative is in front of the x and is not in front of the whole function, it means you have a reflection over the y-axis. And then this here, you're moving right 4 because it's x minus 4. So that's a horizontal translation of 4 to the right. You could, honestly, you could just go to this graph right here and start doing this. So if I want to start right here, reflection over the reflection over the y-axis. So that's 1, 2, 3, 4, 5 away from the y-axis. You go 1, 2, 3, 4, 5 away from the y-axis. And that's already reflected. Now it says 4 to the right. So you go 1, 2, 3, 4, and that's where your point is going to be. Let's take this point right here. Reflection over the y-axis. So it's 1, 2 away from the y-axis. So you go 1, 2 away from the y-axis, and then you do your 4 to the right. 1, 2, 3, 4. And then this point right here, reflection over the y-axis. Since it's right on the y-axis, there's going to be no reflection. Move it 4 to the right. So 1, 2, 3, 4. So you know the graph is going to be doing this. And then, you know, if you want to do this reflection over the y-axis right there, and then 1, 2, 3, 4, it gives you that. And then you know you're going to have your arrow going that way. So let's just graph this. So basically you have this. You have this. And then if you wish. This. Let's make it a bit longer because it's going. And this is basically what the graph looks like after this translation. Yeah. Let's move on to the next question. And you could always go back and review. I have a video, I have videos on transformations. It explains the transformations in details to know what every factor does for you. But that's the way I do it. I just do it from the graph, or take each point and then apply everything here to it. If you could see it from the, this is not complicated, so I just did it straight from the graph. Reflection and then 4 to the right, reflection and then 4 to the right. Okay, next question. Here is another question. Given the following triangle, determine cosecant theta. So cosecant is the reciprocal of sine. So cosecant theta is the same as 1 over sine theta. So since the cosecant is 1 over sine, now we know from SOHCAHTOA, so the sine is opposite over hypotenuse, then cosecant theta would be hypotenuse over opposite. This is the one piece of information that you need to solve this. And then what you need to do is, this is theta that you're looking at, you know the hypotenuse, but you don't know the opposite. So find the opposite. One thing you must know, because this part here goes along where the y-axis is negative, you should put a negative there right away. Now to solve, we're gonna solve for this. We're gonna use Pythagoras. The way I do Pythagoras is basically, you know, a squared plus b squared equals c squared. But you know what? Every time that you're finding the hypotenuse, if the unknown is the hypotenuse, then you go this squared plus this squared, whatever you get, square rooted, and that gives you the answer. If you're looking for a side and you're given the hypotenuse, then you just do the square root of the hypotenuse, which is 5 squared, minus the given side squared, and that's going to give you 25 minus 4, which is 21, square root of 21. So this is basically the square root of negative 21. Pythagoras is simple, you know, you don't have to stick to a squared plus b squared equals c squared. If it is the hypotenuse that you're finding, then you do the square root of side 1 squared plus side 2 squared, and then whatever you find square rooted. But if you're finding a side and you're given the hypotenuse, then you just go the square root of the hypotenuse squared minus the given side squared, and it's that simple. You don't even have to memorize that formula if you don't want to, you know. So therefore, this is square root of 21. Therefore, I'm just going to write the answer right here. Cosecant theta, or cosecant theta is opposite is negative root 21 over the hypotenuse, which is 5. And this question is answered. Move on to the next question. Here's a question from Combinatorics. So for this one, you must remember the formula. MPR equals n factorial over n minus r factorial. So this is n and this is r. So to solve this, I'm going to just apply MPR to find MP2. So therefore, I'm going to have n factorial over n minus 2 factorial according to my formula equals 9n. Now the trick after this is just you want to expand this, because n factorial, or any number, if you have like 8 factorial, it means 8 times 7 times 6 times all the way to 1, you know, sorry, 8 times 7 times 6 all the way to 1. And so what you do when you're minusing 1 every time, and that's what you're multiplying together. So I'm going to take this one on top and expand it that way. So I'm going to have n and then n minus 1 and then n minus 2. But I'm going to put factorial right here because the bottom is n minus 2 factorial. And that way I could cancel and get rid of that factorial sign. And then I have 9n on the side. Now I could solve this by expanding and then bringing everything to one side, equating it to 0. So therefore, I'm going to have n squared minus n when I expand this, when I distribute this in here, equals 9n, n squared minus 10n, because when you move the 9n, it becomes minus. So -1 minus 9 is -10n equals 0. Factor out n, and you get n minus 10 equals 0. And therefore, n equals 0 and 10. Of course, you're going to reject the 0. You cannot choose anything from 0. If you have 0, you cannot choose anything from it. So n equals 10 for this question. This question usually worth about 3 marks. I think easy 3 marks if you know this formula. Let's move on to the next question. Here's another question, topic that I haven't covered yet in my lecture series with Pre-Calc 12. I will get there eventually. Now, this is determine the algebraic value. Sorry, determine algebraically the value of the leading coefficient of the graph of the polynomial function of p of x. So now the first thing you want to do here, you definitely want to write your zeros. So the first 0 you have there is x equals -3, multiplicity of 1, x equals -1. It's a multiplicity of 3. M stands for multiplicity. And then you have x equals 1, and that's multiplicity of 1. Now you could ask me, why is it multiplicity of 1 and why it's multiplicity of 3? Multiplicity of 1, if your curve goes right through the 0, it's a multiplicity of 1. If it goes through it for a bit longer, it's a multiplicity of 3. If it bounces, it's a multiplicity of 2, but we'll deal with that when we get there. We don't have that in there, so just get rid of it. Also, we have a y-intercept. That is -12. So basically, I have a point at 0 and -12 that I'm going to use ahead to find out what my leading coefficient is. So if I start writing the answer for this right here, I'm going to write y equals a x plus 3 x plus 1. And when I write plus x plus 1, because it's a multiplicity of 3, it means it has an exponent of 3. That's what it means. And then I have x minus 1. Now I'm going to use this point 0 and -12 to solve for a. So -12 equals a sub 0 for the x, because that's what x value is, the x coordinate is, plus 3, 0 plus 1 cubed, 0 minus 1. -12 equals a. 0 plus 3 is 3. 0 plus 1 is 1. 1 cubed is 1. If you wish, I'll just write the step. 1 cubed is just going to be 1 and then -1. So -12 equals 3 times 1 is 3 times -3 is -3. So that gives me -3a. Divide both sides by -3. Therefore, a equals 4. My answer is y equals 4, x plus 3, x plus 1 cubed, and x minus 1. That's your final answer right there for this one. Let's move on to the next question. So here's another question. They say determine algebraically if the function of x equals 1 over x plus 5 and g of x equals 1 over x minus 5 are the inverse of each other. So a few ways to do this, but the easiest, just go find the inverse of f of x. So you know, when you're doing the inverse, you consider this as if it was y equals 1 over x plus 5. When we're doing the inverse, all we need to do is just change y to x and x to y. So you rewrite it as x equals 1 over y plus 5. So what I'm going to do, I'm just going to move the y plus 5 to where the x is, and the x comes where the y plus 5 is. I call this free trade. So y plus 5 equals 1 over x. And then just move the 5 to the other side. So I have 1 over x minus 5. I'm going to do a common denominator. The common denominator is, this is over 1, so the common denominator is x. So x divided by x is 1. 1 times 1 is 1. Minus x divided by 1 is x. X times 5 is 5x. And as you see, definitely, this is not the inverse. This is not the inverse of this, because the inverse of this gives me this and not that. So here we're going to prove an identity. Of course, you have your identity sheet in front of you. So the first thing you want to do here, you want to work on the left-hand side. Sine 2 theta is 2 sine theta cos theta. Just let me... So sine 2 theta will just give you 2 sine theta cos theta. And the 1 minus cos 2 theta, you have 3 choices. If you look at cos 2 theta on your sheet, you have you have cos squared minus sine squared, you have 2 cos squared minus 1, you have 1 minus 2 sine squared. There is one that will make your life a lot easier. So here we're starting the multiple choice questions. So if P is 3 and 5 and it's a point on y equals f of x, identify the corresponding point after this kind of transformations. So here, the transformations you have is 1 to the right and 7 up. So that means you add 1 to the x and it becomes 4, and you add 7 to the 5 and it becomes 12. So 4 and 12. And that's your right answer right there. I guess it's highlighted. One more, and then we'll finish this another time. So here, identify how the graph y equals 3 to the power of x is transformed to the graph of y equals 3 to the negative x. We always say that if the negative is with the x, it's a reflection over the y-axis. If the negative was right here, it will be a reflection in the x-axis. So that's definitely a reflection over the y-axis, which is B right here. The next time, we'll continue doing final exams for pre-calc 12. And also we'll go back and start digesting or start breaking down chapters that we haven't covered yet in the course. Till next time, thank you for watching. As always, success in learning is success in life. Stay safe. Have a great weekend. Bye-bye. Stay tuned for my next video. And don't forget, comment, like, share, and subscribe. Thank you again. Bye-bye.